Second part in this experiment is to connect the circuit using analog discovery board and breadboard. So this is the operation amplifier. This is how, of course, it doesn't look like this in reality, but I just connect or added this figure inside it to show the legs. So what we need to do is to take this one here. So this is how we connect the chip. Connect 4 legs on the top and 4 legs on the bottom. So now we know that this leg number 1, 2, 3, 4, 5, 6, 7, 8, because this is the notch here. We have the notch here. And then we have R1 is connected to leg number 2. So here's R1. So connected to leg number 2 like this, for example. So this is leg number R number 1, R1. R2 is connected as a bridge across. Sorry, this is supposed to be like this. You connect it to leg number 2 here, not leg number 1. And this one is connected to the same leg, which is leg number 2, and the output, which is leg number 6. So now I have R1 and I have R2 connected. Next, I want to connect the source. The source is connected to R1, and the source is the yellow. You use the yellow and black. So you have this yellow and you have this black. So let's see, the yellow is connected to the resistor here. So this is the resistor. Let's make it bigger a little bit. You see the source is connected here. So this VN. And the ground is connected to what? To anywhere. Let's see here, for example, or here. Okay. And then we need to connect the ground, this ground, which is this one here. We need to connect it to leg number 3, which is this one. So now I have this leg number 3 is connected to the ground, which is the source. So as you see here, there's the ground is connected to the ground of the source. What's next? We need to have channels. We need to have channel number 1. Okay, channel number 1, it has orange and orange white. Then we need to have this 2 connect to the same positions of the yellow and yellow and blue and black. This yellow and black. Here it is. This one and this one here. So this will be channel number 1. So channel number 1 is across the source. This is the source. So let's call this channel number 1. Channel 1. So let's see here. Channel 1. Channel 2 is connected to the source, to the output. So we have a blue. The blue is connected to the same point here of R2 or to leg number 6. So this is channel number 2. It's supposed to be here. And the second wire, which is the blue with white strip, is connected to the ground. So the ground is anywhere, like here, for example. This is the ground. The ground is this black wire here. So it's any place here or any place here represents the ground. Okay. Now, what is remaining? We need to connect the DC voltage. So don't forget to do that, because until now, this is what we have in theory, that we have this circuit. We do not think about the positive and negative voltage. So, but when you connect the circuit using an analog discovery board, using the breadboard and analog discovery board, or you do it in B2Spice, you have to consider the positive and negative voltage. So the positive voltage is the red wire. So the red wire is connected to what? To this red point here. You can connect it here, for example. So this is the positive 5 volt. And the negative, which is the white is connected to this number 4 here, this one. So let us make it like this, for example, and we can make it white. Make it white. So now we are ready to do the circuit. So once you do this, you can connect it to the analog discovery board. Connect to all these wires, and then you will see the results on waveforms. Now I connected the circuit. Okay, open now analog our waveforms, digital and waveforms. Then what you need to do is to set the source. The source is in wave generator. It is sine wave. You select sine wave. Make sure you have 1 kilohertz. One amplitude is 1. There's no offset, and then you have to press run. Now it's running. So now we have the source. Okay. If you want to see the channel 1 and channel 2, you run it like this. Okay. You have to press auto set to select the value. What happened here is this channel number 1, which is the orange. Okay. Channel number 2 is supposed to be what? Supposed to be negative, the input. Okay, but it doesn't look like this here. So what's the problem? The problem is, think about it. The problem is that we did not set the voltage exactly the same like what I did in B2Spice. But you have to set the positive voltage and negative voltage. So you have to go to voltmeter and turn on this. Once you turn on this, you will see the result right away on the scope. Let's see. Okay, yes. Now it's working. But doesn't show something very familiar. Let us see here if I said auto set. Okay. So now this is just 1 kilo ohm and 1 kilo ohm. So it's supposed to be but yeah, it is now it's clear. When you auto set it, look like this. Okay. Of course, you can show only one period or 2 periods by setting here the maximum here. I need, for example, you have 5 or you have 10 divisions. Then you can select, for example, 200 microseconds, for example. Okay, per division. Okay, so in this case you have two periods, and you see here this is the range is 1 volt per division for both of them. Then now we can compare. This is the input, and this is the output. It is completely opposite to it. Okay. Then when you change the voltage, the resistance, instead of 1 kilo ohm, you make it, for example, 6.8. So what will happen? What will happen? You're supposed to get negative 6.8 sine 2000t. But you will not get this. Why? Because since you have the DC and DC voltage -5 to +5, you cannot exceed this limit. You cannot. You cannot have voltage that's more than 5 volt or less than -5 volt. Because you are running the operation amplifier using -5 and +5. Exactly like if I give you $100 and you go to mall, for example, the mall. You cannot spend more than $100. Makes sense, right? You can spend less, but you cannot spend more. Exactly here, I give the operation amplifier positive and -5 volt. Then you cannot get an output that is more than 5 or less than -5. So now if I connect, for example, here 6.8, let's see what will happen. Now I connect 6.8. See what happened when you connect 6.8. The voltage, the output voltage was clipped, okay, as you see here. But it is not exactly clipped at -5 and +5, because in measurement you usually have a different result from the theory. So if you give the operation amplifier positive and -5 volt, it will not accept the total voltage here. So it may have, for example, 4.5, 4.3 maximum. So here, for example, if you look at this and try to click here, the voltage here is 4.31, so almost 4.3 volt. Okay, so what happens that the voltage is clipped. Why? Because the DC voltage that we have here is -5 and +5. Then you cannot have more than this voltage. And in reality, we have even less than this voltage. Okay, and if you change this one, as I said before in Beto Spice, if you change it to 100, you will have something that's very similar to square wave. So now what will happen if we want to change this to what? To non-inverting amplifier. To do it using non-inverting amplifier, to change the inverting amplifier to non-inverting amplifier, this is how the circuit look like. What you need to do is just change these two positions here. So the source is connected to this input, which is leg number 3, and the ground is connected to the resistor. So this requires us to do what? This is the circuit for the non-inverting amplifier. So this is how it looks like. Okay, if you look at it, you see the difference between them. What happens that X changes the position of the source. So the source now is connected. The ground is connected to the resistor. The source is connected to the other leg here. Okay. Second, you have to make sure also the channel one. Channel one is, this is the orange and yellow and white strip is connected to the ground, and the orange is connected to the yellow. Okay. What else is that channel number 2? This one here is supposed to be connected to the ground. You have to connect it to the ground. Okay. So you have to make sure that this wire is connected to the ground. Okay. So these are the 3 steps. These are the 3 steps. If we want to do this step by step, for example, okay, so this is a non-inverting. Let's say this is non-inverting. Okay, so here it is. Non-inverting. So what we need to do, this one here is inverting amplifier. So what you need to do is to exchange these two. Okay, the position, change the position. Now this is clear. And also exchange these two. So this one is here, and the other one is here. Okay, so this is channel number 1. And this is the source. So number 1, I exchange the source. Number 2, I exchange channel 1. Channel 2 now, the ground is connected, or the blue with white strip is not connected to the ground. It's supposed to be connected to the ground, but it is not. So what you need to do is to move this wire from here to the ground, which is here. So now this will be non-inverting amplifier, and this is what we have in the next slide here. So these are the 3 steps. So what you need to do is to make this circuit and then do the same stuff. You have to change the resistance R2 from 1 to 1.5 to 2.2 and 4.7 and so on. Okay, and after that you try to take a picture for the result and put it in your report. At the end, this is what you need to do. You have to do a formal report, and this is how the formal report look like, or this is the format for the formal report. You have a cover page, you have a table of contents, the objectives. Okay, the objectives are there in the experiment. When you look at the experiment, it has objectives, and the equipment also. Of course, what are kind of equipments you have here? Analog discovery board, the analog parts kit. You have Beto Spice. You have waveforms. So this is what you need. Next part, which is E here, explanation of the operation amplifier. What's the operation amplifier? What is the theory of the operation amplifier? What are the applications of the operation amplifier? You can find this from the internet, of course. You can just Google it. Number F is the real work. So all the steps. So you have 11 steps in this experiment. You have to do it step by step. Some of them are not really work, just explanations. So you can neglect them, or you can just, if you want to write them, that's fine. Okay, and finally we'll have some conclusions that for example, what is the difference between measurements and simulation? What happened when you have the voltage more than 5 volt or negative 5 volt? What happened, and so on. There is a example of or sample for the formal report. You will find it at the end of the lab manual. So it will look like this. You have just number one here. This is the cover page. The cover page has the title and experiment number 9, so the name, class name, this is supposed to be ECEL, instructor name, the date, and then after that you have another page which is the table of contents. Usually when you write a report, table of contents is the last thing to do. So you know this. I hope that you know that. The table of contents is the last thing to do. Why? Because you keep changing the report. After you finish the report, you have to add the table of contents. And then after that, these are the objectives. This is the objective, for example, that what you need to do, the equipment that you used, and software. And then after that, the theory and steps from 1 to 11, and then some conclusions. So this is, I believe, everything you need to know about experiment number 9. So I hope that you do it. And if you have any question, let me know. Thank you very much, and see you in the next experiment.